Hello there, good afternoon and welcome to the Weather Studio Live. It's 1 p.m. It's a Tuesday and it's the 26th of March. We have a great show coming up for you today. I'm Clare and Aidan, meteorologist here at the Met Office.
And I'm Aidan McGivern. We broadcast live at 1 p.m. every Tuesday. Thank you for joining us. This week, a packed show, but lots of interesting things to talk about. We're talking about a rare tropical storm in the South Atlantic. They don't happen often in that part of the world, so we'll be looking at what's going on.
Also good news if you like the dry weather, the bright weather, high pressure firmly in charge. How long will it last? If you are stepping out in that sunshine today or next few days, it might be worth slapping on some sun cream. UV levels are a little bit higher than the climatic average.
And we're going to be talking about technology in this week's Weather Studio Live. We're going to be looking at some of the aspects of our visual cortex weather graphics that you don't often see on the touchscreen presentation. And we have a very special guest. More on that in a moment. But if you do have any questions or comments, please get in touch and we will try and answer as many of those questions as possible.
Now, outside today in the Met Office, we're hosting a really important conference. It's called a Tech Storm. There's quite a lot of information just in those two words, isn't it? It's all about big data. We have some big tech companies that come in, they're guest speakers, and they're talking about big data and how it's of use and a benefit to society. So we have Cray Inc. in, we have TV networks, Microsoft, Amazon, and lots of guest speakers. And one thing we're particularly interested in here at the Weather Studio Live is our supercomputer. It sits over there, it's an iconic building, and that's the reason why we can talk so positively with confidence about the weather forecast, not only for the next few days, but climatic models as well. So yes, we do rely on the supercomputer, but we'd like to know a little bit more about it, wouldn't we, Aidan?
Yeah, and we have got a very exciting guest this week from Cray, the Vice President of Artificial Intelligence. Please welcome Per Nyberg.
Hey.
Thank you for joining us, Per. I know you're a very busy man. You've already given a talk at TechStorm on the future of forecasting, the future of supercomputers, and we're just hoping you'd be able to shed some insights with us now on...
But first of all, tell me about your title, because it's so impressive, isn't it?
It is VP of AI.
What does that mean? I mean, that's really it's up there, isn't it?
Whilst Per is talking, actually, behind you, this is the build of the Met Office supercomputer, so the Cray computer, supercomputer being built there, time-lapse, just incredible, the size of it. Can you tell us a little bit about what you do at Cray, first of all, and then we'll talk about the supercomputer?
Sure, yeah. So artificial intelligence is obviously a major trend, right? I think more importantly is becoming reality. And so this is something that we see, every single one of our customers adopting, machine learning more specifically, whether it's astrophysics, climate, or autonomous technologies. So what I head up is our artificial intelligence group. That's really all about understanding, market requirements, market trends, and ultimately meeting the needs of our customers.
We're at the dawn, really, of artificial intelligence, to be honest, aren't we? I mean, I know it's been going for about 60 years, but it's really only in the last decade where it's been ramped up and we are understanding how to utilize it more and more. I mean, it's everywhere, isn't it?
Yeah, absolutely. I think you're correct. It's been, mathematically around for quite a number of decades. Really what's changed is, the volume of data that you need in order for machine learning to be, usable. But the other thing is obviously the computational power, right? It was really those two things that, sparked the kind of adoption that you've been seeing over the last few years.
And speaking of computational power, I mean, some of the figures are just mind-boggling, aren't they? Here are a few fast facts about the new supercomputer. You might not be able to read all the writing on the screen there. But talk us through this, Per. Thousands of trillions of calculations per second.
Yeah, so there's standard measurements for performance in computing. So flops is just, think of an arithmetic operation, right? So your system does 16 petaflops, which is, a petaflop is a quadrillion, right? Which is, it says there, 16,000 trillion operations a second. Right, so you need that kind of computational horsepower, if you will, to run these very high resolution models that the Met Office does.
And to try and get your head around that number of calculations, I heard that it's something like 2 million calculations for every man, woman, and child on the planet. Yep. Every second. Just mind-boggling. And there's about 1 million lines of computer code to run the Met Office model on the supercomputer. So it's a phenomenal, huge machine. One of the 20 fastest computers in the world. Is that still up to date info there?
Roughly. It's certainly the fastest. The Met Office is the fastest operational weather forecasting system in the world. So that's definitely number one. Yeah.
Why do we need such a powerful supercomputer to run a weather forecast?
Well, I mean, so if you think of weather forecasting, ultimately you are trying to recreate the entire Earth's atmosphere, right? So this isn't something you can do in a lab, right? So you have to model it using a computer program, as you described. And, supercomputers are kind of that, essential calculator, if you will, to be able to do that, right? So supercomputers, I think they were first used in the 1950s to do a weather forecast, right? Back then, it took 1 day to do a one-day forecast, which is kind of pointless. So part of what you're doing now is you're trying to recreate the Earth's atmosphere with as much accuracy as possible, but run it much faster than real time, right? So that's kind of the combination of what you're trying to do and why you need the speed.
There's a well-known law, isn't there, that computers double in speed is it 18 months or so?
Yeah, more that's commonly referred to as Moore's law. That's kind of broken down over the last few years. There's a little bit of debate about that, but I think it's certainly true that the individual processing power of each CPU, if you will, has been slowing. And so in order to run these very large models, what you do is you run them across thousands of processors.
Right.
And I think in your case, it can be up to 15,000 processors just to do one forecast.
Yeah.
Are these computers becoming more intuitive? Are they thinking more like a human brain? Is it something that you can see in the future? Because obviously here at the Met Office, we have a huge amount of scientists and weather forecasters. We do look at the computer model every day and we rely on it, but we add human value. Is that something that we should be concerned about, our jobs, say? Because obviously this is where AI is going.
Yeah, so I mean, look, all scientific advancement has been underpinned by scientists, smart people. Certainly the computers are essential tools in order for them to simulate whatever world that they're trying to model. But, that human element will never disappear, right? You still need those, very smart scientists. And I think what's even more so now as you look into machine learning is the kind of multidisciplinary aspect as well, right? So scientists from different disciplines and domains that are working together. Because one of the interesting opportunities with big data is not just use satellite observations or radar observations, but it could be social media data, for example, right? So there's entirely new domains that need to be explored and made into production, if you will, and the human's never going to leave that.
What does machine learning mean, and what does it mean in particular for weather forecasting?
Yeah, so machine learning is essentially the ability for a model to learn from data, learn from data on its own, right? So I think that one of the areas that's being explored for weather forecasting is that can you use machine learning to better select experiments, right? So scientists don't run one experiment and they're done. They'll run thousands, and these thousands are run over decades, right? And so that ability to look back over all of these experiments and gain insights and help the scientists select where to look, let's say, or select what next set of experiments to run or next set of forecast models to run is absolutely one of the powerful aspects of machine learning.
Yeah, interestingly, this week we've been talking about a new generation of climate models, and our scientists here are meeting with other scientists around the world in Barcelona, and this is like a precursor or platform for the next IPCC report to come out in 2021. And as you said, the word insight, huge insights, particularly about carbon sensitivity. But obviously, there are new generations of computers coming our way as well in terms of supercomputers.
Yeah, so a couple of elements there. So one is certainly that as these climate models become more complex, have a full reflection of the Earth system, right, and all of its processes, they grow in complexity and computational requirements, right, and so that's pretty significant on its own. And then you can imagine running 1,000 of these, right? So that's where maybe machine learning comes in. And so I think what all scientists are grappling with is kind of systems of systems, if you will, right? And it's just become so large and so complex and daunting that they need some, computer-aided approaches like machine learning.
Effectively, previously we would key in instructions for the computer to follow, and machine learning means that the computer can learn from past experience in the same way that a human, and we're often doing it as weather forecasters. We look at a weather pattern and we say, well, from past experience, that kind of weather pattern gives, an overnight frost in these kinds of conditions. And I guess these new machines with their machine learning will be able to look at these past weather patterns, these statistics, and say, oh, I've recognise this from when it previously happened. Is that the case?
Yeah, there's certainly the opportunity to codify human experience, right? I don't think it'll ever replace it entirely, but certainly codify it and provide forecaster aids. But then there's the other insights as well, right? So there's kind of the past experience and there's the new experience that, forecasters and scientists and researchers alike will gain over the next few years as they're running more sophisticated models. So I don't think it's a one or the other, or one's going to replace the other. I think it's really an opportunity for the two to sort of benefit from each other, if you will.
Tell us about the new generation of supercomputers, which we'll probably be experiencing here in the Met Office in the next decade or so. Give us some numbers.
Yeah, so as we talked earlier about the Met Office supercomputers, so those was 15 petaflops, so a quadrillion. The next sort of milestone in computational performance is what's called an exaflop, which is it's 1,000 times that.
Wow.
Right? So it's a billion, right, or a million trillion, however you want to count your zeros, but it's 10 to the 18, right? And so that's a milestone that the sort of science and computing industry has been moving towards for a number of years, and trying to understand the technology challenges and also the kind of application user challenges there. And so last week there was an announcement by the U.S. Department of Energy that the first U.S. exascale machine would be installed at Argonne National Laboratory, be up and running by 2021, and that's a Cray system.
So that's a precursor to perhaps what we'll be seeing here, if we're still here.
If we've not been replaced by your machines.
Me first. Yeah.
Well, thank you very much, Per. It's been fascinating to talk to you about supercomputers, and also thank you for not entirely replacing us by computers. We'll always be grateful for that.
Yeah, and that big data, I mean, it's everywhere now, isn't it? And those numbers are so huge. It's slightly overwhelming, but also really exciting, particularly when it comes to actually understanding environment, the climate much more. So it adds value to our jobs in so many different ways and our lives. It's all about benefiting society, isn't it?
Yeah, absolutely. Great.
Okay.
Well, thank you very much.
Cheers,
Pleasure to chat to you. A really interesting talk there.
Oh, yes.
Let's see if we've had any questions. Christopher Jones on YouTube. When are the 3 months of heat wave on the way? I think Christopher might be reading some overzealous tabloid headlines there. No sign of 3 months of heat wave just yet. But the weather's mostly dry over the next week or so. It's reasonably warm where the sun shines in places. So no heat wave at the moment. But there's some pleasant spring weather out there. We'll be talking more about the weather forecast.
And Philip O'Malley is actually talking. Well, he's an amateur weather fan from Ireland. Hello there, Philip. And he's asking about this cyclone off the coast of Brazil. Is this down to global warming? In fact, it's very interesting because we've been looking at this one, haven't we? It's not a particularly potent cyclone, but it is a rare sighting because they don't tend to develop across this part of the world very often. So this is the South Atlantic. It's the tropical waters of the South Atlantic, and that's the cyclone there. Picking up some wind speed now, though. It's up to around 100 miles an hour in places. And the reason why it's developed quite nicely over the last few days is because sea surface temperatures are a good couple of degrees above average for this time of year. So to create the ingredients for a hurricane or a cyclone or a typhoon, sea surface temperatures have to be above around 26, 27 degrees Celsius. Currently across here, they're 29. The other key ingredient, which we do need for this type of tropical development, is less wind shear, a weak wind shear, which means the winds with height don't increase and they don't change direction. So you get a real development going up into the upper atmosphere. And that's happening right now as well. However, we don't see many of these, do we, at all? I mean,
No.
the last one was
2010.
That was Anita. And prior to that, it was 2004, Katerina. In fact, Katerina was quite a potent beast. And again, it was a rare cyclone occurring off the coast of Brazil, like this one. But unlike this one, it actually made landfall. It made landfall as a Cat 1, Cat 2. In March 2004, a lot of people were injured. Over 40,000 homes were damaged. There was a lot of flooding. Obviously, it didn't have the alert system that we understand now across most of the world, to be honest. The winds were very strong as well. And it was called Hurricane Katerina because it affected a town along this coastline here, just north of Rio. The one which we're currently seeing across the South Atlantic is likely not to make landfall. It could intensify for the next 24 hours or so, but we are likely for it to remain over open waters, which is good news.
An interesting question from Philip, though. Is it down to global warming? I've not seen any suggestions, and I guess there might be studies done to look into it, but these things can, of course, happen without global warming. As you warm the globe, you warm the seas, and you make storms over the sea more likely. But there are other factors involved, which equally might lessen the chances of these things. For example, you mentioned the wind shear. That could change with global warming and lessen the likelihood of these things. So it's a complicated topic. I don't think there's anything I've seen definitively linking it to global warming.
But one of the reasons why we don't see cyclones across this part of the world is for two reasons. One reason is because most of the time we do see quite intense wind shear. That's winds changing with height and direction, with height and strength as well. However, the other thing is that there's not really a convergence zone around this part of the world here, which allows the air to clash and rise rapidly, explosively into the upper atmosphere. And that adds forcing and creates these huge, huge cloud systems, which then rotate. So this one is rare, it is unusual. We are seeing a few in southern parts of the hemisphere at the moment. There's Joanna as well, Veronica and Trevor made landfall across Australia over the last week or so, giving copious amounts of rain. So yes, we have seen some, but now the sun has moved from the southern hemisphere. It's crossed the equator. It's moving up into the northern hemisphere. And so we're anticipating, well, hurricane season across the tropical part of the North Atlantic, which starts around June time. And the first trends to see how intense and the frequency of hurricanes across this part of the world are coming out early April. So we'll keep you posted on that.
Yeah. Last year was a very active season around the world for tropical cyclones, of course, particularly in the Pacific. Now, it is, of course, a lovely spring day in the southwest of England here. I just put this video together for our friends who are attending the Tech Storm conference here at the Met Office. This is showing on the screens out there. Our weather graphics system, it's not quite as impressive as a Cray supercomputer, but it gives us a lot of flexibility to add different weather layers, to turn on and off different weather layers, fade them in, fade them out, and zoom around the world. And you've seen that if you've watched the Weather Studio before with the touch screen. We've got some exciting developments currently happening with the weather graphics, of course, new developments with the touchscreen in particular. So hopefully in the next month or two, we'll start to be able to show those. But yeah, it's a great fun to be able to play with these weather graphics. Let's have a look and see, while that's playing, if there have been any other questions. When will the April showers start?
Well, we might see some on Sunday.
Yeah, classic April showers day. Of course, April showers happen because you've got the land warming up at this time of year, the strong sun, but the air is still relatively cold, so the thermals really get going. And at the weekend, we're going to have a colder feed of air from the northwest, so a classic April showers set up by Sunday in parts of the country. Some decent rainbows, I suspect. What are the chances for another UK hurricane? That's from Moon Reborn, famous for the forecast of Mr. Fish. What are the chances of that happening again?
Many a time, hasn't he?
To be a pedant, it wasn't technically a hurricane because you can't get hurricanes in our part of the world. The sea temperatures aren't quite so high. However, we had hurricane force winds. It was a deep area of low pressure. So yeah, the chances of a similar storm, well, they're always There's always a risk of that in the autumn and the winter in particular, so we'll keep our eye out for those. This time of year, actually, not such a high chance, because this is the time of year that the jet stream enters its weak phase. So it's really kind of during the spring into the very early part of the summer where you get less of a temperature contrast between the pole and the equator, and you get a weaker jet stream and not so many deep lows. Not to say you can completely rule them out, of course. We get all sorts of weather in our country. A question for our guest. Oh, it's a shame that Per has gone now. That's from Chris A. Is it true that the more data you crunch or get, the more accurate forecasts will be in the future? Hopefully, in Per's absence, I can answer this. We'll find out from him later on if I got it right. In a way, yes, you get more accurate forecasts, because if you get a better representation of the atmosphere from the starting point of your forecast, of course, when you run that forward, you're going to get a better forecast. But there's still a limit in terms of being able to see what the weather's doing in every square centimetre or cubic centimetre of the atmosphere, because there are a limited amount of weather observations, satellite data, and so on. And that's why when you reach that point in which you can't increase the accuracy of forecasting anymore because of increases in computing power, we start to use ensemble computer models more. So that basically means running the computer model many times, changing very slightly conditions at the start, and then seeing how they affect the forecast into the future. And then you can see how much confidence you've got in the forecast.
And actually, interestingly enough, at the moment we're seeing quite low temperatures at night across more southern areas and relatively high temperatures by day. And when you look at the average temperatures which the computers are generating, we are going a bit lower at night, adding value to the forecast, and a bit higher during the day because of cloud cover, and because, as you say, on a mesoscale, on a smaller scale, there are lots of local deviations from what the model is suggesting.
Yeah.
So, it's fascinating, and it's something which we are always learning about. We're learning as much about how the model responds to the environment as well as our own experience as weather forecasters.
We're learning, but will the computers
learn
start learning?
Oh my goodness.
And will they be even better at learning? Because they won't procrastinate, will they?
Now, interestingly, Aidan, over the next 24 hours, stratospheric ozone is going to thin a little bit across the UK. And what that means, at the moment, the index is around 3 for UV. It's likely to go up to 4. So we did have a question about suntans and about UV. And there is some sunshine in the forecast, which you'll be telling us about in a moment. But if you are stepping outside over the next few days, particularly during the middle part of the day, then you may find you'll feel the sun on your skin, and you may find that you'll pick up a little bit of colour. So particularly if you're fair-skinned, it might be worth slapping on some sun cream, particularly for kids if they're playing outside. Wear a hat, because with that sun, the sun's rays are now getting a bit stronger, but certainly ozone is a way of protecting us from those UV rays that come from the sun. And at the moment, it looks like it's a little bit thinner across the UK just for the next 24 hours.
Happens every spring. You get a thinning of the ozone layer because of wind circulation and so on, things happening in the stratosphere. And so, yeah, it doesn't make any difference what the air temperature is in terms of whether you burn or not.
No, you can't feel it, you can't smell it, you can't see it, but then at the end of the day, you can see your skin has responded to it.
Except that you'd be wearing fewer clothes, I guess, if it was hotter. That's why you might burn more.
Or the cold onshore breeze, you wouldn't be, would you? My goodness.
No. And if you take a dip in the sea at the moment, it's still pretty chilly, isn't it? Now, let's have a look at the forecast. There's not much to say in terms of the forecast, actually. It's a relatively quiet period of weather in. You can see this area of high pressure. Now, this is Wednesday, heading into the start of the day. Weather front's close to the north of Scotland there, bringing some thicker cloud and some outbreaks of rain as well. There'll be areas of cloud floating around the UK, floating in on the top of that high pressure. By now we're into Thursday, and there'll be some cloud breaks as well. So if you're in the southwest of the UK, there'll be some decent sunny spells next few days. Northeast Scotland as well, eastern parts of England. Elsewhere, some cloud coming and going. Of course, we've got cloud breaks. A touch of frost at night.
Magic numbers during the day?
Well, during the day, by Friday looks like the peak, up to 17 or 18 degrees.
Whoa. That's good, isn't it?
Not as warm as it was at the end of February.
But even so, you know.
Yeah, it's pleasant spring weather over the next few
Particularly,
days.
you know, when I feel so sorry for the mums and dads who have to watch their kids play football on a cold, grey Sunday morning. So this is good news, really, for you guys as well.
Well, it is turning a bit colder into the weekend. This feature here, that is a cold front. It's sinking south on Saturday, clearing away from the south coast at some point during the afternoon. Then we're into this northwesterly airflow. Now let's just zoom out again. You can see those blues returning. So perhaps a frosty one on Sunday morning, and then feeling colder everywhere.
Bright, though.
But brighter.
High pressure.
And as I said before, April showers by Sunday as well. Now, after that, into next week, let's just show where the jet stream is. It's still tending to be roughly to the north of the UK as we go through the weekend, but it's dipping, it's sinking a little bit further south. And the indications are that through next week, we'll be back into a kind of bit more changeable, a bit colder, northwesterly kind of airflow. So, yeah, not as warm in places next week. There'll still be some sunshine out with the wind. It'll feel quite pleasant, but there'll be some outbreaks of rain, a bit more of a breeze as well. So, yeah, not much to say in terms of the UK weather. No snow, no heat wave, no storms. It's just spring-like weather.
We spring forward an hour at the weekend, do we?
That's right. Shortest weekend of the year.
Yeah. So I know kids don't respect that if they still get up early, don't they? But yes, so we really are into proper spring-like weather, solar radiation increasing quickly through the next few months. And yes, we've been quite lucky in March. We've had some wet and windy conditions, but it's been really nice to have some calm conditions away from the northwest of Scotland. So Aidan's 10-day trend, is it you doing it tomorrow, or is Alex?
I think it's me.
It's you. So that will be out tomorrow during the afternoon. You can catch that on YouTube and on other social media channels. And also podcast, Weather Snap, will be out tomorrow as well. We'll be talking about the new climate models. We'll also be talking about the supercomputer and a few other bits and pieces. And the Mostly Weather podcast, which is our evergreen podcast, which tackles bigger subjects, is published on Thursday, and that's a great one. It's debunking weather terms which are overused, misused, and not used anymore.
And Mr. Alex Deacon was involved in that.
Alex
He's got a few strong opinions about weather terms.
Yes.
So tune into that if you dare. Couple of quick questions here. Catherine Jenkins fans on YouTube. Why is my hay fever worse this year?
Well, it's high at the moment for tree pollen.
Yeah, it's tree
south.
pollen at this time of year, and fewer people are affected by tree pollen than grass pollen, but there's still about a fifth of hay fever sufferers are, including Alex Deacon.
And at the moment, with the winds being fairly light, there is some distribution of that pollen, but not enough to mix it into the upper atmosphere.
You can see the blossom on the trees, can't you?
So sorry about that.
And then the Stevenson-Grech family on YouTube. My son is heading for the New Forest tomorrow, few days with school. Well, it's looking good, isn't it? New Forest, a good place to go for
a bit of a diurnal
dry, bright
range.
weather. Yeah, a bit chilly in the mornings, warmer in the afternoon, then mid-teens also when the sun comes out. And finally, another question here. Is it true that the sun, this is from Chris A, is it true that the sun is closer to the Earth in winter than it is in summer?
Yes.
It is true. It is true. The northern hemisphere is tilted away from the sun. That's why we get winter. But the Earth as a whole is about 3 million miles closer to the sun in the summer, or in the winter, I beg your pardon, than the summer. And that's to do with the eccentricity of its orbit. And we've got an interesting video on our Learn About Weather channel on YouTube that explains all of that. So, yeah, the planet as a whole is closer to the sun during the winter, but what makes it more important is the tilt of the Earth. That's why winter.
Yeah, seasons.
Yeah, seasons. And, yeah, that's about it. Thank you for your questions. Thank you for watching. We'll be back again this time next week. But for now, bye-bye.